B.Sc Part 3 and respected listeners, a very good morning and welcome all of you to today's lecture. Dear students, I will deliver lecture on LCO treatment of hydrogen molecule ion, which is taken from B.Sc Part 3 Paper 3 Physical Chemistry, selected from Unit 2nd Molecular Orbital. I bring to draw your kind immediate notice, first of all, about important previous postulate of LCO method. Dear students, by using various mathematical concept equations and quantum mechanical concept yesterday, we mentioned equation number 3 on the blackboard in matrix form here. Let us derive equation number 3 today by involving on the behalf of fundamental conceptual of mathematical and quantum mechanical conditions. Try to understand to derive equation number 3. The title, the next part of LCO method for hydrogen molecule ion, that is the calculation of energy psi1 square, C1 mixing coefficient and E2 psi2 square, C2. It is next part of LCO treatment of H2 molecule ion. Now we derive equation number 3 yesterday I have mentioned on the blackboard by using quantum mechanical postulates here. Dear students, I am writing here equation number 3 E is equals to integral psi molecular orbital H psi mo d lambda upon psi mo d lambda. I am writing here on the behalf of previous quantum mechanical postulates. You have to write directly here the expression regarding of energy. Here you know here that is of energy, inside that is of expected value, average value, energy is regarding to that is of H. As you know, Schrodinger wave equation one can write modified form H psi is equals to E psi. Say equation number M equation. Now put down 1 in M equation. Equation number 1 psi molecular orbital yesterday I have mentioned in our personal notes C1 psi of A plus C2 psi of B. After substituting the value of equation number 1 into this M equation, E is equals to C1 psi A plus C2 psi B. Psi molecular orbital will be as such, hydrogen will be as such, psi molecular orbital will be replaced by C1 psi A plus C2 psi B d lambda. Similarly, in the form of denominator one can write here psi molecular orbital C1 psi A plus C2 psi B. Similarly, psi molecular orbital C2A plus C2B, that is of d lambda, said that is of n equation here. After the multiplication, on solving this one n equation, we have the quantity that is of E is equals to C1 square, which is constant, inside integral that is of psi A H psi A d lambda plus 2 C1 C2 integral psi A H psi B d lambda plus C2 square psi B H psi B d lambda. Here in the form of equation number n, denominator here C1 psi A square d lambda plus 2 C1 C2 psi A psi B d lambda plus C2 square integral psi B square d lambda. See that is the O equation here. Now apply the fundamental equations which we are using here in above equation number that is of O. By normalization condition here psi A square d lambda psi B square d lambda is equals to 1. By normalization condition here similarly H A psi A H psi A d lambda, similarly H B B another one function psi b, h psi b, which is known as that is of Coulomb integral. Next one HAB, HB, psi h, h psi b d lambda, psi b, h psi a d lambda, that is of resonance integral. In our previous lecture we have defined these various kinds of integral in our lecture, say Q equation. Next one that is of SAB, psi a psi b d lambda, say R equation, that is of overlapping integral. All these standard values put down into that is of equation number, that is of this O, we get very specific result which gives us an important information which is beneficial, which help us to calculate the value of that is of E1 for symmetric energy level, psi 1 square electronic charge density for bonding, C1 mixing coefficient, E2 energy level for anti-bonding asymmetric, psi 2 square that is of electronic charge distribution for anti-bonding, C2 that is of next mixing coefficient. We will calculate it, that is of tomorrow. Thanks a lot.